So now we're going to work on direct and inverse variation. We're going to focus on direct first, and then inverse variation. Now, to be honest with you, direct variation is not actually tested in Math 2. They test inverse variation, but what they've been doing in the past is doing a combination or a joint inverse variation. So that's part of the reason why we need to learn direct. So direct variation is anything that's in the form of y equals k times x. Okay. This k value is called the constant of variation. And some of the questions you may just be asked to find the constant of variation. So just kind of make sure you're careful with your questions. One of them in your homework only asks you for the constant of variation. Others will ask you to go to a step farther. So in order to find k, you have two methods. You can either, one, plug in an x and a y that go together, kind of that plug and chug method where you're just kind of plugging in, an x and a y that go together, so you plug in the x, you plug in the y, and then just solve for k. The other thing that you can do is, since it's in this form, y is equal to k times x, if you were to try to get k by itself, we would just have to divide by x. So an easier or shorter way to find your k value is just take whatever the y value is divided by x. Both methods will work to find your k, but like I said, if you can remember that it's just y divided by x, it's a little bit faster to find it. Okay, so if you need anything from the screen, go ahead and get it. We're going to look at a couple direct. So usually they're set up something like this. If y is equal to 4, when x is equal to negative 2, there's a negative 2, find x when y is equal to 6, if y varies directly. Sorry, that's coming out really, really sloppy. My pen is just not writing well. Sorry. Directly. There we go. With x. Now, again, as soon as you see somewhere in the words that can have it in the front, it can have it in the back, but as soon as you see that word varies directly or direct variation, automatically it means that you're dealing with this form, that y equals k times x. So you have to have an x and a y that go together. And these problems will always give you an x and a y that go together. And in this case, it's our very first part of our first sentence. It says right in there, y is equal to 4 when x is equal to negative 2. So that's the x and the y that go together. So either of the two ways to find your k, again, I will just usually do whatever y is divided by x. So in this case, my y is 4 when my x is negative 2. Which means that my k is negative 2. So there's my function. I'm just plugging in negative 2 in place of x. That's my direct variation equation. So if the question had just asked you for your constant variation to be negative 2, you'd be done. If it asked for the equation, we just wrote our equation right there. There's our equation. But oftentimes it'll ask you to go a little bit farther, like it does in this problem. It says find x when y is equal to 6. So we plug in 6 in for y, and we just find the x that goes with that. So we divide by negative 2, I get that x is equal to negative 3. So there's my solution. And this is what most of your homework questions are going to look like. On the homework, don't type in x equals negative 3, just type in the number that it's supposed to be equal to. Right, so if you need anything from this one, go ahead and get it. Okay. Let's try another one. Let's say if y varies directly with x, and let's say y is equal to 7 when x is equal to 2. Okay, find y when x equals 3. Pen, alright, so again, as soon as I see that word varies directly, I know that I'm dealing with a y equals k times x. So I have to go through and find my k value. So again, the easy way to find your k value is just do y divided by x. And you look at the x and the y that go together. So in this one, it says y is equal to 7 when x is equal to 2. So there's my x and my y that go together. So if I do 7 divided by 2, okay, you can either do, in this case, 3.5, or you can leave it as 7 over 2. It does not matter. It's kind of up to you. Anything that came out to something like this, on your homework, I had it where it would mark it correct either way. So if you're more comfortable with doing the decimal, that's fine. It's not going to matter. It's my constant of variation, so this is my equation. All right. Now it wants us to go a step further. Find y when x is equal to 3. So 3.5 times 3. Let's see. This one I end up getting 21 divided by 2. Let's see, which is 10.5. I'm pretty sure. Let me just double check, make sure. Yeah, 10.5. Okay. So again, if you have, you can put it in as a fraction on your homework, or you can put it in as a decimal. Either way works. Alright, so those are direct variation. The only other thing I want you to be able to do with direct variation is determine from a table direct variation. So if you need anything from the screen, go ahead and get it. I'm going to clear it off. Alright, so let's say I had this table. Let's see, 2, 4, 3, 6, 5, 10, 5.5, and 11. Okay, so if I want to determine if this is a direct variation, again, direct variation, if I have a constant k value, it should always be whatever my y is divided by x. If I do that for each of these numbers in the table and it comes out with the same k, it's definitely direct variation. So if I do 4 over 2, I get 2. 6 over 3, I get 2. 10 over 5, I get 2. If I do 11 over 5.5, I also get 2. So since I have the same k value all the way through, this is a direct variation, and my equation would be y equals 2x. Alright, now we're going to switch gears and start looking at some inverse variation. So if you need anything from this screen, go ahead and get it. Alright, inverse variation is, let me make this inverse. Inverse variation is anything that is in the form of y equals k divided by x. Okay. So if you hear those words varies inversely or inversely related, it's y equals k over x. And just like with direct variation, the first thing we're going to have to be able to do is find our k value. Now the k value is even easier to find with these. It's actually the multiplication of the x and the y value, which finds your k. So let's see, our first example, suppose x and y vary inversely. And inversely, when x equals 3 and y equals -5, find y when x equals -30. Okay. So again, as soon as I see the word varies inversely, I automatically know that I'm dealing, with a y equals k over x. Again, I have to find that k value first. So just like before, we're going to find an x and a y that go together, which happen to be right here. And to find that k value, all I have to do is just multiply the x and the y. So in this one, 3 times -5, which gives me -15. So this one has the function y equals -15 over x. There's my inverse variation equation. So this one takes it a step farther. It says find y when x is equal to 30. So all I have to do is just plug in 30 in for my x value, and I get a y value equal to -1/2. Okay. So inverse variation is very similar to your direct variation, the same kind of idea, just a little different setup of an equation. And again, find x and y that go together, find the k value, and then continue on. Alright, so the last thing that we're going to look at is getting an inverse variation equation from a table. Okay, so let's say I had this table, 10, 1, 5, 2, 2.5, and 4. Okay, so again, to find a k value, for these, again, k value for inverse variation, if we're testing that, you should be able to multiply the x and the y and get the same number. So if I do that for each of these, 10 times 1 is 10, 5 times 2 is 10, 2.5 times 4 is also 10. So I have consistent k values, which means this is an inverse function, or inverse variation, and my k value is 10. So that would be my equation. So yours are drop-down boxes on your homework to just determine the types. You're going to have to try to find k, and try to see if you can find it by dividing y and x. That will tell you if it's direct. Multiplying the two gives you inverse. If it's neither of those, then it's neither.